Okay, so what we're going to do today is, let's see, we've got OSPF running on this network, and we are going to set up a access control list, an ACL or ACL. We're going to set that up on R5, and that ACL will describe which clients are able to be natted out dynamically, or if you happen to be a client on the internet, how you can actually reach a particular device inside our network by using a publicly accessible address. You can see in here we're using 172.16s. What kind of addresses are those? 172.16. You?
172.16, those are...
Because you got like a 10.0.0.0 and a 192.168.0.
Yeah, that'd be a Class A.
Okay, well 10 would be a Class A, but are they public or private addresses?
Those are private.
Yeah, they're private, meaning they are not going to be routed on the internet. The service provider will block those. So what we need to do if we want to be able to reach clients on the internet from internally on our network, we are going to have to use a public address. And that is the function of NAT. NAT is network address translation. It's going to allow us to use the address that's either assigned to this interface so that we can get out to the internet, or use, if we're coming in from the outside, use some public address or publicly accessible address that is being advertised by our service provider using, and they'll be using BGP, and they'll be advertising that to the rest of the service provider routers. So what we want to do is, first off, let's just test some basic functionality. I don't know exactly what the configuration is. We've been called in as consultants to work on this. So let's go to R5 and let's console in. We're using GNS3. These are 3725 routers that are configured here, and let's go to config T, and let's just do a do show IP route, not router, but route. And just real quickly, I'm going to change the color so that makes this a little bit easier for you to see. The foreground will be black, and the background is going to be blue. Unfortunately, I have to change that a couple times, but on that router, we have a static route right here. It's a default route on R5 that says, hey R5, if you receive any traffic that doesn't match one of these addresses, send it to 37.136.55.194, which is the ISP or our service provider interface. So our default route from this network, which would be considered basically a stub network, is to send any unknown traffic to our ISP, because we assume that the ISP knows how to get pretty much everywhere, and that'll be the way they function. Let's go to R6, and let's do the same thing. On R6, let's go in and let's do a show IP route so that we can tell what the routes are on R6. Apologize for taking this time to change these colors, but it'll make it a whole lot more legible. On R6, we do a show IP route. We see that we have got a static route down here at the bottom, but we have no default route. And it wouldn't make sense. This R6 in this diagram is our service provider's router right here. And the service provider router would probably not have a default route. It's certainly not going to have a default route pointing into our network. So what we want to do is we see that we've got a directly connected interface right here, 37.136.55, and the address on R5 is 193. The address on R6 is 194, and we see that that network is shown right there. That's the network, the /28. So the network number has the 4th octet of 192. There's no default route. Now, we have an option here. We can allow, since our R6 knows how to get to the 37 network, which we have got a subnet on there. R6 knows how to get there. So if all the traffic came from this interface, R6 would know how to send it back if it had the source address of serial 00 on R5. Does that make sense?
Yes.
Because it would be like, we know where this guy is, and we know how to get back to him every time, because we have a directly connected interface right here. If we go to R7, I'm not going to change the colors on this, but I just want to do a show IP route there, if I can type correctly. There's no gateway of last resort set there either. Once again, that's another service provider network out there somewhere. But we do have a route to the 37 network, which we just looked at on R6. Notice that there's a B over here, meaning that R7 learned that route with BGP. It also learned this route, the 75.1.2.192 route. It learned that one with BGP also. That's the static route that's configured on R6 that points to that network. And that network we could use for a variety of purposes because R7 knows how to get to that network. So the first thing let's do is set up real quickly Static NAT on R5. So if we go back over here to R5, not R6, not R7, here's my R5. Okay. And we want to, first off, with NAT, is identify the inside and outside interfaces. Which one is an inside interface over here?
The fast 00.
Yeah, fast 00. This fast Ethernet 00. That's the one that's connected inside our network over here. So we just need to identify that quickly and easily. We can go into config mode and go into the interface, fast Ethernet 00, and just type IPNAT inside. That tells our router that that interface is connected to the inside of our network. And I see that we have a little bit of an issue on that particular device, and that is that it may not have enough memory on it. And one of the cool things is, let's go ahead and just save our config and let's stop that device. We are going to go into the config mode, click on the device, go into memory, and let's change our RAM to 256. And then let's just start her up again. It's a little quicker and easier to do it on the simulator than it is on a piece of live equipment. But once R5 is back up, it's starting right now. There's our memory showing up. And what we're going to do is we're going to set up a static NAT mapping so that clients out on the internet can get into our device. Now, why would we use static NAT?
Static NAT.
Remember when we have a web server that's inside our network that maybe has a private address, or a mail server that's inside our network that has a private address, or maybe SharePoint or some other device that's inside our network using a private address? We want to make that so that people out on the internet can connect there and get our web pages. Or that email servers out on the internet can forward email to our internal web server, and they're going to have to come through our edge router or our firewall. So we can set up static NAT to facilitate that. Let's go into config T on router 5. Let's go into interface fast 00 and just do the IPNAT inside once again. And the external interface, the outside interface, is which one?
Serial 00.
Right, so it's serial 00. So if we go to interface serial 00, we can just say IPNAT outside. And the nice thing is, if I do we want to verify NAT, we can do a show do show IP NAT translation. Now, because I'm in the config mode, I have to put the word do in front of that command. And I see that there are no NAT translations right now. And so let's go and look at back at R6. Okay. And I can see on R6 that we are forwarding this 75.12.193 network, 192 network, excuse me. We are forwarding that into our network right here. And if I looked at the route, I see that I've got it in my routing table. If I do on R6, if I do a do show run, and I want to go look at the actual routing statement, I can see this right there. It's got a 240 subnet. Now, from our subnet that we just did, how many addresses would be available using that 255, 255, 255, 240?
14 hosts, be 12 addresses.
Well, it'd be 16, right? 256 minus 240 would be 16.
16.
So there would be actually 14 host addresses. 240 would be the network. 255 would be the broadcast. So we can use 241, 242, 243, all the way up to 254 for usable host addresses inside on the actual client. So that is the range of addresses from 240 to 255 that's actually being forwarded into our network. So what I want to do is I'm going to copy that, because I like that little bit of information right there, and I'm going to put it up on the page right here so we don't forget. So what we want to do is we want to set up, let's say for instance, that we want to be able to reach this loopback 3 down here on R3 that's got the address of what? 172.16.3.1. We want that to be reachable from an address that falls on this range right up here. So pick one, 75, 1, 2, let's use the first one, 193. So the public address, what we're going to call the inside global, that is the address that this interface inside our network is known as globally. We call that the inside global. That's the address that people out of the internet are going to be able to reach. 75.1.2.193. And it's going to be coming through this router, which will translate it and forward it over to R3's loopback rate. So this is really pretty simple to set up. So the cool thing is, once you understand how it works, it's really very easy. We've identified the inside and outside interfaces. We're setting up Static NAT. So this is Static NAT. Network address translation. And we want to do just a simple Static NAT statement. So we're going to type IP NAT. It's always going to be inside. And the source, where's the source of the traffic? If we put a question mark, we've got some different options here. The option we're going to use is it's static. It's a static map. And then what does it ask us for? The inside local IP address. So right here on this chart, this is the inside local, and this is the inside global address that is going to be used to reach that machine that we are trying to configure a connection to. So static, what's the inside local address?
172.16.3.1.
That's right, 172.16.3.1. And if we need it, we got context-sensitive help, and it says, what is the inside global address? Well, that makes it pretty easy if we just look at the information that's available with the context help there. 75.1.2.193. Now, I probably should have tested some basic connectivity, and that's what I'm going to do right now on R5. I just want to make sure that that loopback is actually functioning so that I can reach it from a network router that is actually configured on my network. I'm going to do a do ping, and you should do this as well. 172, 172.16.3.1. Oh, I can't reach it. Okay, so we may have a little OSPF troubleshooting to do. On R5, let me do a do show IP route. And all I see right now, oh, I don't have my OSPF functioning. Bummer. That means we're gonna have to set up OSPF pretty quickly here. On R5, what's the first thing to do to set up OSPF?
Router OSPF1.
Router OSPF1, and I want to put a router ID on there of 5555. And the only interface I want to put into the routing process is this fast00 with the address of 172.16.245.3. So the statement will be network 172.16.245.3. We're going to put our quad 0 so we exactly match that interface, and then put it in there as 0. I want to make sure that in case somebody makes a mistake and misconfigures something, that we never send a hello out serial 00. So let's make that a passive interface serial 00. And let's do a do copy run start and hit enter to save that configuration. Real quickly, we're going to have to go to these other routers, and we're just going to do a blanket statement that's going to put all of them into the routing process. So if we go to R2, we could say config T, router OSPF1. The router ID on that's going to be 2222. Now, it doesn't, okay. Wants the dash ID. I'm just not sure what I'm doing here. Okay. You have to type properly. The network statement that's basically a catch-all will be network, quad 0, quad 255, area 0. And there's an adjacency that's formed with router 5 immediately. For a few seconds, let's go to R1 and do the exact same thing. Config T, router OSPF1. The router ID is going to be 1111. And the network, once again, is quad 0, quad 255. Now, we probably wouldn't use the quad 0 and the 255s on a production machine because it will put all the interfaces in a routing process. But it's possible we might want to do that, and I'm just doing it to save time. We now have adjacency with router 2. So if I look at the show IP route, I'll see that I've got, right now it's just showing the directly connecteds. And now the OSPFs have appeared. Tell that because of the O's over here. Which one are you on?
Router 3.
Oh, you're moving ahead, huh?
Mm-hmm.
All right, so we're going to go to router 3. I'm going to do config T, router OSPF1. The router ID will be 3333. The network, quad 0, 255, area 0. And then I'm going to do the same thing on R4. So we're going to get all of these routers participating in the OSPF process. Once we've got that, we got loading is going to full. I would expect that on R5, going back to R5, that maybe we can see, if we do a show IP route, that we have some OSPF routes now, and quite a few actually, and the 3.1 is showing, 172.16.3.1. So if we hit the up arrow a few times, bring back that ping command, we can now ping that host. So that was a quick configuration of OSPF. So this loopback is now reachable from R5. We set up, if we do on R5, to verify our NAT configuration, do show IP NAT translation. Notice that it shows us that we've got a translation that's set up. The inside global is the 175, excuse me, the 75.12193. That's the address that this router, which is inside our network, what it's known as globally out here on the internet. Inside our network, locally, to these clients that are local, it's known by its actual address. If we go out here to R6, let's go back out to R6, and let's do a ping for the loopback, excuse me, the inside global, the 75.1.2.193, and we should see that that device is accessible from the internet. Of course not. So on R6, let me do a do show IP route 75.1.2.193. We neglected one thing. On R5, we need to share the default route. Because if I go over to R3 right now, and I look at R3, and I see what's your routing table look like, do show IP route, that router has no way of getting to the internet. Gateway of last resort is not set. Where can we set up, or we already have a default route set up on R5, how would we go about sharing the knowledge that R5 is the edge router and has a default route? How would we share that with the other hosts?
The default information originator.
Very good. So the command is going to, there's two ways of doing it. We can use a redistribute static, but for a default route, we usually use default information originate. Then, once we've done that, that's going to send a link state advertisement with an update out to the other routers here. And if we go back to R3 and we do a show IP route, we should see that we now have a default route shown right there. Gateway of last resort is now configured, where just a moment ago it says it was not set, now it is set. And let's go back out to R7, where we previously did our ping. Oh, we didn't do a ping from there. Did we do a ping from there?
We did it from
R6?
R6.
So let's go back up and do our ping, and now we have success. Woohoo! So our static NAT is now running perfectly. Real simple process. Identify the inside and the outside interfaces, and then create the NAT statement that's going to NAT a particular address from a global address to an inside address, inside local. Let's do another one. Let's pick another interface or device that we want to be able to connect to. In fact, let's do this. Maybe we want to be able to Telnet into R1. So if we go to R1, let's set up a loopback. Let's set up interface loopback 1 and put an IP address of 1111 and then a quad 255 on that. And let's go back. Let's share, and that address now is shared with OSPF because we use that catch-all for OSPF. If we come back to R5, let's say, we do a show IP route, we'll see that we now have the 1111 network showing up right there. And let's make sure that R1 is configured for Telnet. How can we do that? Line VTY 0 to 15. We'll put a password of Cisco login, and I'm going to put an exec timeout of 00 because I don't want a screensaver to log me out. And I'm also going to put a logging synchronous, kind of boilerplate stuff. And just to make sure we have a password on there, I'm going to enable secret of Cisco. And I also want to put an IP domain name of tty.com and generate some cryptography keys so we can use secure shell if necessary. So what's the command for that?
Encrypt. You already got it. Sorry, I was.
Crypto key generate modulus, and then I'm going to use a 1024 modulus on it. And it is creating the cryptography keys. So we should be good. I'm also going to create a username of Cisco with a password of Cisco. And I just decided because we're going to be using secure shell, I want to put login. I want to go into the VTY and do login local. So we'll be required to use that username Cisco, password of Cisco in order to log in. All right, so we can get into the 111 machine if we have a path to it. So on R5, could we create a static route to get us there?
Yes.
Yeah, we can. And let's use the 1111 as the inside local. And for the outside address, we're going to use 75.1.2.194. How's that sound?
That's good.
That's the next address that is in the range starting at 192 that goes to 255. So on R5, we can just do another static NAT statement, IP NAT. From the inside, the source is what?
1111.
Well, the source is a static list. And the inside local is 1111. And the global is 75.1.2.194. If I do I want to see the NAT translation just to verify. Do show IP NAT translation. And there I can see the mapping is there.
Give me a second to catch up.
Okay, so after we get that configured, let's go ahead and we'll go to R7 again. And first off, let's just see if we can ping 1111. Of course we can't, because it's not being advertised to the internet. There's no path to that on R6, our internet service provider router. But what about telnetting into, well, let's try a ping first. Ping 75.1.2.194. Okay, we have success. So we're using a public address. We're able to ping into our network to a machine that arguably has a public address 1111. But we can actually reach it, and if we wanted to, we could telnet to that same address. And log in. And now we're connected to R1. And we are in full control of R1 from our internet router. The great way we can use this is on an edge router. We have a Cisco small business router on the edge of our network here, and we set up a static mapping to allow students that maybe were at home to be able to actually log into our network. And then we can, I'm actually recording this right now, give me just 5 minutes. We'll allow them to connect up to a device inside our network where we can let them configure live equipment from home, which is actually how most network configuration is done. So just to recap, we did the inside and outside interfaces. We did our static NAT statement, which maps the inside local to be accessible from an inside global address, which is publicly accessible. Any questions on that?
Nope.
Cool.